Everyone. So today we're going to be going all things naming for test one. This video is also going to be really helpful for the problem set and great practice for the test. So there will be a few things that Dr. Berg may not cover in class yet, but he will get to. So this is helpful to get a head start or as a refresher once he does cover that. So I'm going to start off with going over some important things that I think you need to know and kind of like tips and tricks to help you do well for naming on the first test, which is a very big part of the test. So the first tip that I have is to memorize all of the prefixes. There really is no shortcut to memorizing them. It's just practicing, looking over them, and making sure that you know them because they're very important. And Dr. Burke used any of those that he gave you on that chart, so I make sure to know them all. The second tip that I have is to prioritize the longest chain. So Dr. Burke will give you a lot of different molecules, and some of them will be relatively easy and a lot shorter, but some of them will be very complex and have a lot of branches, and they can be a lot more challenging. So it's always really important to focus on what the longest chain is and kind of like you can use a highlighter on the test, and that's very helpful to kind of show that. Now, the third tip that I have is to look at the lowest numbering system. And what I mean by that is, so if you have a 355 numbering system on a molecule, then you have a 244 on another molecule, a 244 system is much more preferable and would be the correct answer on the exam. I'm kind of going off of that. So if we have a tie in the molecule, such as let's say bromine and chlorine, two groups, both have A2 as their lowest number possible, but one of them's on one end, one is on the other end, we'd want to then look at alphabetical order. And in this case, bromine, since it's higher up in the alphabet, it would take priority just over chlorine because of its name. The last tip I have is pretty simple. It's just to practice. And when I say practice, I mean practice a ton. Do pretty much every single one of the naming problem sets, do the textbook problems, do the practice test, watch this video, do the practice problems that I'm going to be doing in here multiple times. Make sure that you understand all of the naming conventions, and the more you do, the better it'll be on the exam itself. So now kind of moving on to functional groups. These are groups that take priority over some of our branches. And the first group that we have are alcohols. And alcohols are an OH group written like this. They can be found on the ends of the molecule, on the main chain, anywhere. So definitely be looking out for those as they're very important and help to name the entire molecule. So with naming, alcohols, you drop the E from the parent chain. So methane, we go to methan, and then we add OL. So methane would go to methanol. Now our second group are amines, and these look like NH2. Dr. Berg may not be here yet in your class, but he will be getting to these, and they're also very important. So the naming for these kind of works very similar. So we're going to once again drop the E off the end, so methane to methan. And but this time, instead of just adding two letters, we're going to add amine. And the reason we're dropping the E for both of these is because we don't want two vowels together, and the E gets dropped, and we just add those suffixes. Now, with alcohols and amines being functional groups, they're not equal. So alcohols take priority over amines. So if you see an alcohol group and see an amine group on the same molecule, that amine group is going to turn into a branch and will have a different name that we'll talk about in a little bit. So alcohols right now are our number one priority group, and we'll be through OChem 1. All right, so now going on to branched groups, these include your halogens, the methoxys, your alkyl groups, anything like that. And there's no priority based on the group. Now, I will say, look at the lowest number system as well as alphabetical order for naming the molecules of branches. Okay, so one of the first branches we'll look at are just our alkyl groups. So these are our CH3s, CH2, CH3 kind of groups that are attached to our main chain or our parent chain. And so when naming these, like it says alkyl, so it's going to be, so alkane is the original name. We're going to drop the A and E, and then add YL. So alkane or methane goes to methyl. And now our second group for our branches are our halogens. And these include, we have fluorine, chlorine, bromine, and iodine. And so none of these take priority over one another based on what they are, except alphabetical order does matter. And then once again, the lowest numbering system also matters. So with the halogens, for example, we'll do chlorine. So chlorine looks like this. So we're going to drop the I in E and then add an O. And this works the same for all of them. So fluorine goes to fluoro, bromine goes to bromo, and iodine goes to iodo. Our last main branch group at the moment are our ethers. And these are kind of, we designate as OR, R just being any carbon chain. So we could have a one carbon ether being a methoxy, and they can get up to whatever size they want to be. So with naming, we'll look at methane once again. So when you have an ether, in this case would look like this, you once again drop the A and E, but now we add OXY. So methane goes to methoxy. And that's kind of a crash course on the functional groups and the branches. Now we're going to get into some practice with some basic molecules and structures. So like I was mentioning earlier, a good tip to have for naming is to highlight or make sure you can easily see what the parent chain is. So this first one right here is pretty easy. So we're just going to go through and highlight our main chain right here. And now with numbering, it always helps once you highlight to number the main chain. So in this case, we can go 1, 2, 3, 4, 5. That's one direction. Or we can go 1, 2, 3, 4, 5, the other direction. And so in this case, our red number system would give us a 3, 5 number system overall, but our purple system will give us a 1, 3. That 1, 3 is much more favorable than the 3, 5. So we're going to start with our chloro being our 1 group. So with that, 4 is going to get a 1. And all numbers and letters are separated with a dash, as I wrote right there. But everything else is written together in one long name. So there won't be spaces in between certain names. It's just one long continuous name. So then we have a methyl group. That's going to be on our 3 carbon. So another dash, and a dash on that side to separate the letters again. Methyl. And then our main chain is a 5 carbon parent chain. So that's going to be pentane. So overall, our structure right there is 1 chloro, 3 methyl pentane. It's not too bad, pretty easy to start. So now moving on to another one. We can first highlight our longest chain. So we're going to go this way and down. And then we're going to number once again. We're going to go 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. So in this case, it's pretty clear which one is more favorable. We have that iodine right there on the end, which has a 1. And then our first group going the other way wouldn't be until a 4, and it's the same either direction in that case. So we're going to start with our iodine. So our name's going to be 1 iodo. You see iodine, drop the I and E and add an O. And then we have 2 methyl group branches right there on the 4th carbon. So in this case, we're going to do 4 dimethyl. Always make sure that you are including the prefix for however many groups you have of the same kind and putting both of the numbers, even if they are the same, just to show like where they are as the locant. And then looking at our main carbon chain, we have 1, 2, 3, 4, 5, 6, 7. And this is going to be heptane. So we have 1 iodo, 4 dimethyl heptane. Not too bad. So moving on to the next one that we have. This is also very simple. Highlighting the main carbon chain, and then we'll number. So this one's going to get into the alphabetical order issue, because we have 2 branch groups, neither one of them taking priority over one another normally. But in this case, bromo is the more alphabetically favored since it's further higher up in the alphabet. So in this case, our red numbering system is going to be the direction we want to go. So we're going to have 1 bromo, and we're going to have 4 chloro. And since we have a 4 carbon chain, we'll use the prefix bute, and we'll have butane. All right. Now moving on to our last practice problem for these type of molecules. We're going to once again highlight. This is something you should always be doing on practice, test, homeworks. This is really helpful. Then we're going to number. So red, we're going to go 1, 2, 3, 4. And then purple, we're going to go 1, 2, 3, 4. So with this, we have a methyl group, and then we have an ethoxy group. So if we look at it, red is 2, 3, purple is also 2, 3. So once again, we have to look at the alphabetical order for these groups since neither one of them is a priority functional group. So E comes before M in methyl. So ethoxy is going to be our first. So we're going to go with the purple numbering group. So it's going to be 2 ethoxy. Make sure you're looking, so ethane would be just the 2 carbons right here. But when you have that O, it turns into an ether. And then we drop the A and E and add OXY. So 2 ethoxy, 3 methyl. And just like the last one, we have another butane. So butane. And that's all for that one. So now moving on, we're going to talk about branches. So branches are a little bit different. They can be kind of confusing. You won't see them a lot, but they would definitely be on the first exam and are something good to know. So we're going to do a little practice here. So with branches, we have our main chain. That doesn't really matter in this case. We're kind of just looking at what's attached to it. And so we first want to highlight the longest continuous chain of the branch. And then after that, you want to look at what carbon in that chain is attached to the parent or main chain. So I'm gonna do a little practice with this. So here we have a 3 carbon chain, and this is pretty simple. It's in a straight line right there. And so normally this would be a propane group, but in this case, it's not going to just be propane. Let's see, we will write in blue. So right here, we can number, we can go 1, 2, 3. So the second carbon is the one attached that is attached to the main chain. So this branch is going to get the name propan to ill. So this 2 right here is just the carbon attached to main chain. But it still works the same as any other branch name. Propane going to propanil. It's just except this time we have a locant showing like which carbon is the one attached to the main chain. So we'll do the same over here for this other branch. So here we have a 4 carbon branch. We're going to go 1, 2, 3, 4. And you could number the other way, but that would give you a 3 as the one attached to the main chain, which is not favorable. So we're going to stick with the blue number that we have here. So we have a 4 carbon chain, so it's going to be this would be butane alone, but as a branch, become butan to ill. So these kind of follow the same rules, but definitely make sure that you at least understand the naming conventions and practice a little bit with this because this most likely will be on the exam. And it's a pretty easy 2 points as long as you know what you're doing. So now we're going to move on to some alcohol and amine naming. So these are kind of the first naming with the functional groups that take priority. So let's see. We'll highlight the first one here, going through our main parent chain, and then we're going to number. So our left numbering is going to be 1, 2, 3, 4, 5. Then numbering from the other direction, 1, 2, 3, 4, 5. So with alcohols, in any group really, you want the lowest numbering system, but alcohols will take priority. So if there was another group present, even though the alcohol might be like on the other end, it wants to always have the lowest. So in this case, we're going to follow our purple numbering system. So our chain right here is a pentane. So it's going to be pent, and then it's on the 2 carbon, pentan 2 all. This is a pretty simple alcohol. Dr. Berg would definitely make them a little bit harder than this. But this is pretty basic just to kind of see like how to name them. So moving on over here to this one. This one's a little bit more complex. We have some other groups that are also present on the chain. So we're going to highlight once again, going through our longest carbon chain, and we're going to number. So we're going to go 1, 2, 3, 4, 5, 6, 7. And with numbering, this also kind of helps you see how many carbons are in your chain rather than having to like sit there and kind of count them one by one every single time. You can just go through and number them, which will help you a little bit. Okay, so we have purple numbering being a 3, 6, and the red numbering being a 2, 5. So starting off, looking at it, the red numbering looks really good. That 2, 5, the 2 is better than the 3, and so is the 5. But you have an alcohol group, and the alcohol is going to take priority. So with this, we're going to make our methoxy group over here a branch. So it's going to be 6-methoxy, and then we're going to insert our parent chain name, which in this case is a heptane. So it's going to be hept, and then we're going to look for the number. So it's a 3 for the alcohol, heptane 3 dash all. So these are cases where the number system is not as favorable, but the alcohol needs to have the lowest number possible. And giving it the 5 is not ideal in this case, so it gets the 3, which makes the methoxy a 6. So moving on a little bit, this one is a diol. So diol just means 2 alcohols, very simple, and nothing much to it. So we're just going to number it. We'll go 1, 2, 3, 4, 5. And that side's going to be our 1, so we're going to start there. So it's going to be named the same as before. So pentane being our parent chain. And usually with alcohols, we drop the E. But when we have a diol, that is not the case. When we do this, we're going to go pentane 1 or diol. So that di right there is a consonant, and you're able to leave the E. You actually have to leave the E when you have a prefix such as di or tri, if you had a 3 alcohol system. And so definitely remember to always keep the E when you have a consonant, but to always drop it when there's only 1 alcohol. So moving on, now we have an amine. Amines follow the same conventions as earlier, as I mentioned. And you can go back to that part of the video if you need to look over those notes. So we're just going to number, we'll go 1, 2, 3, 4, and then 1, 2, 3, 4. So we have a 1, 3 system, and then a 2, 4. So that 1, 3 is much more favorable than the 2, 4. So we're going to go with that one. So we have a methyl group right here. So it's going to be 3 methyl. And then we have a 4 carbon chain. We're saying that's going to be bute. So butan. And remember, so with amines, it's another vowel. So we're going to drop that E. Butan 1 amine. And in this situation with the 1 being right there, you could leave it out. You can leave it. It's kind of up to you. Just make sure you're dropping that E since there is a vowel right there. You could also write this as 3 methyl butanamine. It's a redundant one, but it's rather be safe than sorry. So just include it, and then you won't get it wrong. So this next one's a little bit different, and this is a special case that you will possibly see on the exam. But I definitely want to go over it for you all. So our main chain is pretty simple. It's just the 5 carbon chain right there. We're going to number that. So we have a 1, 2, 3, 4, 5, with our amine group being on the end right there. But so when we have a CH3 attached to an amine or to a nitrogen, it's going to be denoted as N-methyl. The N just showing that it's attached to the nitrogen. So this is very important to know. Definitely remember that when you see a CH3 attached to a nitrogen, that it's like this. And sometimes there could be 2 attached, and then it would just be N-dimethyl. But in this case, we're going to start off with our chloro group first. So it's going to be 3 chloro because of alphabetical order. And then N-methyl. And with our 5 carbon chain, we have another pentane. So it's going to be pent, and drop the E since we have an amine group, and then 1 amine. So you can see the names get kind of long sometimes as you kind of are going through, but just always remember numbering first, always have the lowest numbers, and then you want to focus on alphabetical order after that. Now we're going to move into a special case of when we have an alcohol and an amine group together. So we're just off highlighting the main chain and we're going to number. So we're going to go 1, 2, 3, 4, 5. Or we're going to go 1, 2, 3, 4. So like I mentioned earlier, alcohol, greater priority than NH2. I have to remember that. It's very important because Dr. Burke could possibly give you a question like this, trying to trick you up a little bit, but alcohols always take priority. So in this case, we're going to use the red numbering system. And so when an amine is a branch, we're going to have, so let's see, branch. What do you call it? Amino. So instead of amine, you call it amino with an O. So our name is going to be 5-amino. We have the 5-carbon chain, hint, and make sure we drop that E for the alcohol, and 2-all. So 5-amino, pentane, and 2-all. So that will be the end of part 1. I decided to split up this video into 2 parts since it got a little bit long. But definitely come back to watch part 2 if you want to help with cyclic naming, as well as some more niche things that you could potentially see on the exam, as well as do some problem set practice.